tidbits that came, and then this week I got one last one. I said, okay, this completes the picture. I gotta make a video and a blog about this. Because it's a combination of different technologies. Now, mind you, these are all techs that are proof of concepts and prototypes in laboratories. They're not deployed yet, which means entrepreneurs outside, like you guys, can take this tech and make it something commercially available for homes and commercial enterprises and industries and whatnot. And what's really exciting about all this is really about a very old energy form, which is hydrogen. Hydrogen is everywhere. On the planet and the universe. It's the most abundant atom, but there are some issues, like it's highly combustible in gas. So it's a gas, so it takes huge volumes. It's hard to transport safely. It's hard to store safely because it's so combustible. And if you want to transport it like in a more manageable way, you have to bring it down to a liquid, for example. But that's like minus 252 degrees Celsius. Anyway, there's a whole bunch of issues around handling the hydrogen, because once you start burning it, like in a combustion engine, for example, like that is adapted to hydrogen, you're making pure water. That's it, energy and pure water. So it's wonderful. But we have to resolve the other issues. Now, the technologies that I've accumulated that are since probably December 2016 until now, they talk about really innovative techniques, membranes, catalysts, and materials that allow us to extract, to both treat non-desirable compounds from the air or in organic wastes, and converted those into hydrogen gas using only water at room temperature. So you're not spending energy to make hydrogen. Literally, you're using light as a source of energy with catalysts in a nutshell. So we can basically convert, for example, there's a lab that converts lignin, which is something that's present in wood, paper, and leaves and organic materials of that sort. And with light converts into gas, into hydrogen gas. So you can use, and then you can store it and you reuse it as a combustible, as a form of energy. Other team has been using like a filter with some catalyst just in the air, because in the air there's a bunch of organic compounds and water, most of which include hydrogen. So this catalyst membrane combination at room temperature just kind of converts passively these compounds into more inert, less problematic compounds, and sorts out the hydrogen so you can reuse it and do something else with it. Awesome, environmentally friendly. You're cleaning the air, you're reducing some of the organic waste, and you're making a hydrogen gas. Now, that's not the only thing. We also figured out how to do photosynthesis, which is what plants do with the chlorophyll and the green part of the plant, the leaves, to create energy. They create glucose from CO2 using light. The photosynthesis we're talking about with the research that I read about, taking CO2 and we're making things that are more like more akin to solar fuel. So it's I forget the compound. Solar fuels, anyway. It's very simple. It looks like methane, methanol, methylamine, I think. Yeah. Anyway, formaldehyde, and anyway, the names would come to me later. I don't have the list in front of me. My article talks about it. If you look at the blog, and you have all the links over there in the down below as well. And those can be used as combustibles safely as well. So if we produce CO2 as part of the processes, and also we can manage to extract some of the CO2 from the atmosphere, which is a greenhouse gas, among other things, and bring it into a usable type of energy that is way healthier. Now, a lot of the things I look at as well is, okay, that's fine, all these catalysts, what are the materials needed to actually make this? Because if we need to make a whole bunch of them, and the materials needed are very expensive for the environment and pollutant, it's not so good either. Well, most of those techniques that I have down below, the catalysts are easy to make, and they don't pollute in their creation, except for one which uses cadmium. But it is a catalyst, and it's not terrible. Okay, and that's the one that is used to break down organic material, at least some of the organic material. It's not that bad. We're using cadmium a whole lot. If it's used as a catalyst, it's not as bad. We're probably going to process and hopefully refine and find another type of catalyst that does the same job, maybe over more types of organic materials. Because ultimately, what I'm seeing here is different techniques that can be used in a home with different systems, where we gather air using sunlight. We gather air to recycle a lot of the organic matter and also the pollutants we put in the air ourselves, which is carbon dioxide and methane and some of the gases that we produce inside the home by just living, and our animals and pets and things like that. And you generate electricity through the production of hydrogen. Now, the transportation issue has also been further resolved, because what we do nowadays, as one way to bypass the dangers of transporting hydrogen or the cost of bringing it down to minus 252 degrees Celsius, is by converting it to ammonia. Like ammonia is converting hydrogen and nitrogen to ammonia is like an old recipe. It's used. It's cheap now. It's very easy to do. And nitrogen is in the air. 79% of our air is nitrogen, so it's easy. It's right there. And hydrogen, of course, is what you want to preserve. It's converted into ammonia. Ammonia is liquid at room temperature and not dangerous, not flammable. You can transport that in pipelines and trucks and whatever you want to destination, and then it can be easily reconverted. And there is a nice group that created a. I'm putting the link down below, that created a way to ensure that this final conversion to hydrogen is hyper efficient, creating very pure hydrogen, so that it's even more environmentally safe to do the conversions, because there's always a loss when you convert things to other things, and bring it to a home or business, so that hydrogen can be used, or it could be like a gas station for hydrogen, for example, which is the model they're mostly talking about. But I'd rather think about further into the future, where you have your self-sufficient inside your home for all your energy needs. And that will be a little bit further down the line, but still something we can look forward to. So lots of really great things as far as energy generation, transportation around the most abundant energy source and cleanest burning energy source in the current universe that we know of, being hydrogen. Now, one final point of interest, because we were talking about hydrogen and energy, there was an article that I had read, I think it was in December, this one, about the fusion reactor, the Heiselstein 7X fusion reactor, which, if you know about fusion, you're taking hydrogen, compressing it into a plasma at 80 million degrees Celsius inside a very strong magnetic field. And the hydrogen atoms fuse together to make helium, which is also harmless in the air. And that generates huge amounts of electricity. It's completely green, completely harmless, except that there's lots of pressure and energy, like in one spot, like one reaction. It's not something that inherently would explode. It's more of a question that would, if a mishap happens, a lot of stuff would melt, like inside the actual reactor. There's no emissions or anything like that would occur, like Chernobyl or Fukushima and things like that. So that's something to look forward to as well, if they're able to finish their project, which is very soon. The Heiselstein 7X is very promising as perhaps the first real fusion reactor as a prototype that would work to generate constant fusion. So it's like having a mini sun on the Earth. And then essentially using a system like that, even though it needs to be distributed just like any other plant from a central location, because it's huge and very expensive and very delicate as far as equipment is. Expensive equipment, not necessarily delicate so much. Then the electricity needs to be still distributed through networks. But it's still an infinite amount of electricity, because it uses hydrogen, which we can derive from the atmosphere thanks to new technologies. So very exciting times as far as energy, as far as everything, really. We just need entrepreneurs like us and or socially responsible individuals or ecologically responsible individuals to push these technologies forward, so it goes into the hands of engineers that make these things into practical tools we can use in our day-to-day and buy into it or promote and all that stuff. And then we solve a whole bunch of issues around energy generation, pollution, and everything else that we've been worried about over the past number of years. So let's keep it up, guys. I hope you enjoyed the video. If you like what I'm doing, please feel free to subscribe, promote, and share these videos. The more viewers I have, the more information is spread about these things. So that's my goal. I'm not here to make money. So hopefully you enjoy and you're helping me spread the word. For now, that's going to be it. But I will come back next week with another installment of something.